SciCuriousID presents a truly fascinating and insightful look into a common household trick that, at its core, elegantly reveals the fundamental principles of physics. This simple demonstration holds a surprising depth of scientific explanation. Watch closely as the presenter expertly flips the glass upside down, a card pressed firmly underneath. Then, with a steady hand, they release their grip, and the card miraculously holds the water perfectly in place, defying what our intuition might tell us should happen.
Behind every question lies discovery. I'm Saluna, and this is SciCurious, where we uncover the science shaping our world.
It truly looks like an act of magic, a glass of water floating upside down, seemingly defying gravity itself with no visible support. But behind this simple science trick lies one of the most elegant and accessible demonstrations of physics that we encounter in our everyday lives, often without even realizing it. So, the burning question is, why doesn't the water fall out of the glass? Let's delve deeper and explore the invisible yet powerful forces at play that make this seemingly impossible trick not only possible, but entirely explainable by science. The floating water trick has been around for centuries, captivating audiences and sparking curiosity. It has often been used by teachers to illustrate scientific principles and by magicians to amaze audiences with its seemingly impossible and gravity-defying nature. Long before people truly understood the concept of air pressure and its pervasive influence, it seemed utterly impossible that a thin, flimsy card could hold up an entire glass of water against the relentless pull of gravity. It was a genuine mystery that puzzled many. However, after the pivotal 17th century, brilliant scientists like Evangelista Torricelli and Blaise Pascal made groundbreaking discoveries. They revealed that air isn't merely empty space, but rather a tangible substance with measurable properties. These pioneering scientists revealed that air is, in fact, a vast sea of invisible weight, constantly pressing on everything around us with considerable force. This atmospheric pressure is a fundamental force shaping our world. Here's what's really happening in this intriguing experiment. When you fill a glass with water, carefully place a card over its mouth, and then confidently flip it upside down, gravity immediately begins to pull the water downward, as expected. But the card doesn't fall, and the water stays contained, because the surrounding air pressure pushes up from below with significant force, effectively counteracting the weight of the water inside the glass and holding everything in place. The atmosphere around us exerts a remarkable force, roughly equivalent to 101,325 pascals at sea level. To put that into perspective, this is approximately the same pressure as having 10 tons pressing down on every single square meter of surface. This immense and often underestimated pressure from the atmosphere is more than enough to hold the card firmly in place against the glass, effectively and completely counteracting the relatively small weight of the water contained inside the glass. Think of the air beneath the card as an invisible, yet incredibly strong, cushion pressing upward. As long as the seal between the card and the rim of the glass remains perfectly tight and unbroken, the upward air pressure underneath is significantly stronger than the downward force exerted by the weight of the water above it. The water's own surface tension also plays a crucial supporting role in this trick. It helps to maintain the integrity of the seal between the card and the glass, preventing any air from slipping inside and breaking the delicate balance of forces. Surface tension acts much like a flexible, invisible skin around the water, particularly at its edges. This skin is created by the strong cohesive attraction between individual water molecules, pulling them together and forming a resilient barrier. This powerful combination of external air pressure pushing upwards and the water's surface tension maintaining the seal makes the card stick to the glass. However, once you tilt the glass even slightly or inadvertently break that crucial seal, gravity instantly wins the battle and the water dramatically falls out. You can definitively prove that air pressure is the real hero behind this trick with a simple yet profound test. Attempts to perform the exact same trick in a vacuum chamber, where the surrounding air has been removed. Without any air pushing up on the card from below, it will drop immediately and the water will spill. This is precisely what Evangelista Torricelli demonstrated when he created the first barometer, conclusively showing that air itself has measurable weight and exerts pressure. Fun fact, the very same principle of air pressure differences is what keeps massive airplanes flying high above us. Air pressure differences created above and below the wings generate the necessary lift, utilizing the same fundamental laws of physics that keep your glass of water magically suspended. From the simple suction cups that hold objects to walls, to the advanced technology of vacuum-sealed food containers that preserve freshness, our everyday world is absolutely full of moments where pressure quietly and effectively defies gravity, often without us even noticing. What initially looks like a clever magic trick is actually physics, at its most elegant and accessible as a beautiful demonstration of the constant balance of invisible forces that we are immersed in every single second of our lives, shaping our reality. So, the next time you witness the captivating floating water trick, remember this important lesson: it's not an act of magic or illusion. It's the powerful and ever-present atmosphere doing all the remarkable work, a testament to the wonders of physics. Stay curious with SciCuriousID. Are you curious for more fascinating scientific explanations and intriguing demonstrations? Then be sure to subscribe and continue to stay curious with SciCuriousID for more engaging content.
There's always more to discover. I'm Selu, and this has been SciCurious. Stay curious, and I'll see you in the next wonder.